In today's video, we're going to walk through the built-in logging and profiling web interface and how this UI can help you dive into the events and performance of your database, Redis, message queues, and external web service integrations. As your systems grow, it can become difficult to get visibility into the different parts of your service endpoints and which systems they interact with. For example, you might have a service that reads and writes to a database, interacts with Redis for caching, sends a message to a queue for offline processing, as well as integrates with third-party SaaS products via HTTP. When issues arise, like having endpoints time out, the ease of finding the root cause is closely related to the level of visibility of relevant information you have about your systems. To make this kind of analysis easier by default, ServiceStack has request logging and profiling built into ORM Lite, the Redis client, message queues, gateways, and HTTP clients. This data can be traced using a built-in web interface that links logging and profiling together. This additional context to your service endpoints added to logging and profiling can make finding the root cause to a problem a lot easier by giving you a step-by-step breakdown of events for a given request. To better illustrate how this works, we're going to walk through using the profiling and logging admin UIs, looking at the different operations we can profile and trace out of the box. These include the plain ServiceStack services, ORM Lite database calls, ServiceStack Redis client commands, message queue services, service gateway calls, and external HTTP API operations. We will create a new project and walk through adding example functionality that illustrates each type of event and how they present in the logging and profiling admin UIs. Before we get started, you'll want two things installed: the .NET 6 SDK and the ServiceStack.NET X tool. If you don't have the ServiceStack.NET X tool installed, you can install it using the command .NET tool install -gx. For those who have existing ServiceStack projects and want to quickly enable this functionality, let's look at how to add the logging and profiling admin UI to existing projects. The minimum requirement for using the profiling and logging admin UIs is that your project already has an auth repository registered and the admin users feature plugin is already added. If you already have those two features, we can use the xmix profiling command from our project and we will have new menus in the existing admin UI. This will enable you to look through your request log and trace all the events related to each request. To get a better breakdown of how all this functionality works together, we are going to start from the beginning and create a new web project using the ServiceStack.NET website. Navigating to ServiceStack.NET and clicking on the Get Started button at the top right, we will be greeted with a project template generator. Here we can select the type of project we want, optional features to mix in, provide a name, and click on the project template we want to download. To jumpstart our project, we can select the features required to use the profiling and login admin UI. They are auth, an auth repository of RDBMS, profiling itself, and SQLite to store our user data. This will incorporate all the features we need to use the admin UI, including the profiling and logging feature. Additionally, we're going to add the support for Redis and background MQ so we can demonstrate the different types of events we can see in the profiling UI. Providing a name and clicking on the web template, we will download a zip file of our newly created solution. Unzip the solution to a local working directory and open it with your favorite .NET IDE. Once opened, we will see the standard 4 projects commonly used with ServiceStack templates. These include the app host project, the service interface project, the service model project, and the tests project. If you want to learn more, check out our app host fundamentals video and documentation, but for now the rough overview is the app host project is used for configuring our host, the service interface project is for our service implementations, and service model project is for our request and response data transfer objects or DTOs. Our solution has everything it needs to support running the admin UI, including the logging and profiling features, but we still need to add the admin users feature plugin to enable the admin UI itself and create an admin user so we can log in. We can add these in the configure.authrepository.cs file in the configure app host before configuration action. We can uncomment the code that creates an example admin user and add a line that adds the admin user's feature plugin to the app host instance. Since we included the Redis functionality, we'll run an instance locally using Docker, run our application for the first time, and we will be greeted with the Hello API page of the standard web template. Here we will see some links to the built-in web UIs of the API Explorer. Clicking on the View API Details link, we will see all the info about the Hello API in an easy-to-use web interface. At the top right, we can see a sign-in button, and we can log in with our demo admin user. Once logged in, we will see a Dashboard and Users button, which links to the admin UI. Clicking the Dashboard link, we will see some basic stats of our hosted application, as well as an indicator of enabled admin UI features. The Logging UI surfaces all the data captured by the Request Logs feature plugin and presents it in a way that's integrated with the profiling feature. For example, if we click on the Logging menu item, we will see several entries related to the Hello service and authentication. Clicking on the Hello GET request, we can see our request is broken up into different parts. At the top, we have the request DTO data followed by the response DTO data, which is presented in 3 different views. Next, we have the HTTP headers, where we can see all the related request header data. Additionally, we can see the data in cookies and JWT if enabled. Back at the top, we have several links related to this request. These can be used to filter logs and relate the request log to a profiling event. For example, clicking on the path after the HTTP verb will filter the request logs to just logs that use this path. The Hello link below can do the same with the operation type used, which will include all requests that use that request DTO. Next, we have the user, which will be present for authenticated requests, enabling us to see all the requests this user has made. The IP address and session ID can also be used in this way to filter request logs. The trace request link will jump us over to the profiling admin UI so we can see all the internal operations related to this specific Hello request. Here we can see just 2 entries for this operation of request before and request after. This gives us timing information about how long this request took to finish. If we go back to the logging menu and click on the auth request at the top and click trace request, we can see there's a lot more going on. Each row in this list is a profiling event that has the same trace ID. When a request is started, the trace ID is passed through the different parts so we can see the related events to a request even across different threads. In this example, we can also see that we have a source value of ORM Lite with events related to commands and connections to our SQLite database. Clicking on the first ORM Lite command after event with the message value of select shows the SQL used by this event. Just by looking at the event here, we can see the full SQL as well as the parameterized values that were used in this query. Looking at the order of the profiling entries of this trace, we can get an idea of what took place when, and with the additional context of message, user ID, duration, and the time, we can nail down any slow running operations and see exactly where in our stack issues might be occurring. In this trace, we can also see Redis events accessing the user session. Since we registered Redis as a feature, it is used for sessions and caching automatically. If we look at a successful authenticate event for a new login, we can see Redis is used for creating and persisting the new user session. Not only do we see the exact commands that are sent to Redis using our Redis client, but we see it in the context of all the other commands in our system for this specific request. Profiling events also extend to message queues as well. To demonstrate this, here we'll create 2 new services. One wired up to our background MQ, and one a normal ServiceStack service that we can hit through the API Explorer. The clear cache requests can be hit by a normal HTTP endpoint through API Explorer. This will publish a message to our background MQ service and return straight away. Another thread will pick up that message queue task and call the clear cache background service, clearing the cache from Redis. Viewing our logging UI, we can see that both the clear cache background and the clear cache requests are logged separately, one with a session ID and one without. The MQ service doesn't have a session ID since it was processed in the background. Clicking on the Clear Cache event and tracing the request, our profiler has linked our events across threads and all the related data is accessible. Service gateway requests are another type of operation that's profiled. Service gateways are used for composing internal or external services together, where you can call a service without explicitly specifying the request's destination in the service implementation. This means by using service gateways to reuse your service code internally, it keeps the interactions between your services loosely coupled if they need to be hosted separately in the future and accessed using features like automated service discovery. For example, you might have a service called Get Customer Orders that pulls data from both the Get Customers and Query Order services. Initially, these services are within the same app host, so using Gateway results in an internal call. However, gateways enable the ability to break these two services off into separate app hosts without changing how you call that code. Once separated, having profile data in your consuming app helps with identifying what might be causing an issue or slowdown. Here we have an application that uses the Northwind sample database with code-first auto-query services, and we've created a new Get Customer Orders service that utilizes two auto-query service requests via the service gateway. Our profiling admin UI now shows gateway before and gateway after events, where we can clearly see the order of events and the duration. So since these are in-process requests, we can see the related ORM Lite events as well. However, if we moved the two auto-query services to be hosted on different app hosts and access them as external HTTP services via a custom service gateway, we would see them as client events instead. This is because we are using the standard .NET HTTP client to make the call to the external service. Client events will be picked up if you use the built-in .NET HTTP client anywhere in your code during the service, including in your dependencies. This means if you use external third-party SDKs that utilize the standard HTTP client in .NET, you will see these in the profiling admin UI as well. Here we are using the OctoKit GitHub.NET client and making an example call from the README. Looking at the profiling admin UI, we can see the GitHub API calls and important info like how long the request took to complete. And in your own code, if you utilize the ServiceStack HTTP clients like the JSON API client, even more details like the data in the request and the response will be visible in the profiling UI. Having request logging and profiling built into your ServiceStack applications means you have better visibility into your systems just by adding two plugins. They work together in the built-in admin UI so you can enable them quickly when debugging issues without any external tooling. You can see system-specific info from SQL queries, Redis commands, message queue values, external HTTP integrations, all from the same interface. Tracing between all these facets of your stack is automatically built in, giving you a clear timeline of events to better diagnose your systems. Well, that's it for this video. If you have any suggestions or feedback about our templates or videos, let us know in the comments. If you want to know more, check out our other videos and join us in the ServiceStack community through our Discord and GitHub discussions. ServiceStack is free for individuals and open source projects, so anyone is welcome. And as always, thanks for watching.